You want to understand the physical quantities, work, energy, and power. So in the examinations, they will ask like this: define work, energy, power, and write its units and also the dimensional formula. This is a short answer question. We'll understand first work. This person is applying a force on this car. If there is a displacement, then work is said to be done. When we are applying a force on the body, if there is a displacement, then work is said to be done. That is the definition. So, what is the definition of work? Work is said to be done by a force when a body undergoes a displacement. So, when there is a displacement by the application of force, then only work is said to be done. So, work is said to be done by a force when a body undergoes a displacement parallel to the line of action of force. What it means is the displacement and force should be in the same direction. Or we can say work is said to be done when there is a displacement in the position of a body by the application of force. That also is a definition for work. Work is measured by the product of force and displacement of the body in the direction of force. Here, you know that force is a vector quantity, displacement is a vector quantity, but this work is a scalar quantity. Here, it is a scalar product or scalar quantity. So, the beauty here is they ask, when two vectors are multiplied, can any physical quantity belong to a scalar quantity? Best example is work. Even the force and displacement belonging to vector quantities, but the product is coming as a scalar quantity. So, work is a scalar quantity. So, by the application of force on the body, if there is a displacement, work is said to be done. That is the definition. Here you see in this one, here the force is applied at an angle. So, what is the angle here? The angle here is, if you see this angle, it is theta angle. There is an angle between these two. What is the angle? Theta. Here, the body is moving in the horizontal direction. And the displacement is a d, or sometimes you can say s. Both are same. Both are yes. So, what is the force in that horizontal direction is F cost of work. What is the definition is? Work is equal to the force component in the displacement and a displacement. What is the component of force in the horizontal direction? It is F cos theta. Because the vector quantity, it can be resolved into two components. In the horizontal, F cos theta. Vertical direction, F sin theta. But I want here horizontal component, therefore F cos theta is the force component. Displacement is S. So it is called Fs cos theta. So this is the formula for the work done when a force is applied at an angle. So it is Fs cos theta. So actually, if you want to show, it is a dot product. That is F dot S. So if you expand it, it is called modulus F into modulus of S into cos theta. Theta is the angle between the two vectors. So here again I can emphasis on this one. The work is a scalar quantity, but force and displacement belong to vector quantity. The units of work is nothing but here you see it is force into distance. That is why Newton, or it is simply called joule or joule. So what is the definition of joule? Joule is the amount of work done when a force of 1 Newton moves a body to a distance of 1 meter in its own direction. So that is the unit for joule in MK system or SI system. In CK system, what is the unit of this work? Work is a unit. If you see here, in the case of this FPS system, the foot pound is a unit for it. Now, 1 joule is nothing but 10 power 7 ergs. 1 joule is equal to 10 power 7 ergs. That is a conversion very important for 2 marks. Now, we are going to write the formula, dimensional formula for work. So, what is work? It's a force and a displacement. You know, it is a dot product. Don't mistake it. It's a dot product. Force dot displacement. Force is nothing but ma. How? By using the formula F is equal to ma Newton's second law. So force is mass into acceleration into displacement. What is the dimensional formula of mass? M. Acceleration Lt minus 2. Displacement is L. So if you simplify it, it is mL square T minus 2. So this is the dimensional formula of a work. mL square T minus 2. So in the dimensional formula, you have to keep a square bracket. Now I'm going to talk about energy. Energy is nothing but the capacity of doing work. Energy means capacity of doing work. Is called energy. You see here, and she is lifting this weights, so she has the capacity of lifting. Whereas you see these two examples, this person is not able to lift the weights. He is not having sufficient energy. So energy is less, capacity is less. So the capacity of doing work is called energy. Here, work and energy are same. Therefore, what is the unit for this one? Same as the previous. And it is a scalar quantity again, energy. What is the dimensional formula? Same as work, mL square T minus 2. And what are the units? Same, joule, ECG system, earth. Because it's one and the same as work. So, the units of work and energy are same, dimensional formula are same, both are scalar quantities. Power. Power is nothing but rate of doing work. So power is nothing but rate of doing work. See here, the rate of doing work is called the rate at which work is done. Or rate of doing work is called power. So what is rate? Nothing but time with the time. Work done by time is called power. So what is the formula? Power is equal to work by time. And this power is nothing but average power what we calculate. So sometimes people will do the work very fast, the power is more. If they are going slowly, the power is less. So you know motor power 5 HP, 10 HP, that is called power, horsepower. So that is about the power. Power is nothing but rate of doing work. So we are going to discuss about now the next one. Now we are going to calculate here. We are talking about instantaneous power. That is a power at a particular time. The power at a particular time is a ratio of small work done to the small time interval of dt. But as you know, work is equal to F dot ds. And therefore, power is equal to F dot ds by dt. But you know here, ds by dt is called velocity. Therefore, it is F dot v. Or you can expand it as power is equal to F dot v, or it is equal to mod F mod v into cos t, where the force and velocity are acting at an angle theta. And therefore, the power is nothing but Fv cos t. So we have two formulas for this power. It is Fv cos theta or power is equal to work by time. Both are one and the same. Depends on the data given, we have to take. Now SI units of power is joule per second because it's work by time. And it's also simply called watt. What is 1 watt? If 1 joule of work is done in 1 second, the power is called 1 watt. Watt is equal to 1 joule per second. What's the dimensional formula? Power is work by time. Work by time, work is force, displacement by time. The force is mLt minus 2. Displacement is L, time is t. And therefore it is mL square t minus 3. So dimensional formula for power is mL square t minus 3.